This is your fourth shape in conics, section 10.4, hyperbolas, and these shapes are going to be ones that where you have the perbola in here, it sounds like a parabola, and it's kind of like that. It's a parabola shape except there's two of them and they go back to back, not touching but facing outwards from each other. Either they go side to side or they face up and down. There are still features like centers and foci, asymptotes, all sorts of stuff that you've seen before, but that's the basic shape that you're going to be seeing today. The two formulas for these are going to be this here, where you're equal to 1 on the side, and you're going to open to the left or to the right when x is in the front, because notice these formulas have a minus sign between the x squareds and the y squareds. So it opens up down when you have the y squared as your positive term in front. So that's what this is down here. When y is in the first numerator, it opens up down, and when x is the first numerator or is the positive, it opens left right. We already said it's equal to 1 always. There's a minus sign between them. You still have foci, and those foci are found with this equation. Notice that unlike your ellipses, it's a plus sign between them. So this is actually the difference between ellipses and hyperbolas. Ellipses have pluses in the original equation and minuses in the foci equation. Hyperbolas, it's the reverse. Minus in the original, plus in the foci. We'll talk about asymptotes here in a second and why those become important. But let's go ahead and let's start by looking at a graph and talk about the equation of the graph. So write an equation for each hyperbola. First thing you want to notice is that since this one is a side to side, that means that we're going to have the formulas that have x squared in the front and then the y squared in the back equal to 1. Now, if you look up top at the equations in your notes, you see that there are a squareds and b squareds. For ellipses, it made a big difference which number was larger. For hyperbolas, we don't actually care which one is larger. We only care about what's the x-y's distance and what's the y-y's distance, or horizontal and vertical, which is the same as ellipses as well. So from your center here, how far are you going until you hit the hyperbola's arm? We're going 8 units. So that needs to go underneath the x squared because it's the x distance. Now, unfortunately, there's no shape for us here, so we don't know how far we're going upwards. When you had ellipses, you had things like x squared over 5 squared plus y squared over 3 squared equals 1, and you knew that that meant go out 5 units to the x distance and go up 3 units and down 3 units for the y distance, and you connected these and made the ellipse shape. But here there's no shape up there, so what are we touching? Well, what we do see in here is we do see the focus distance. So this distance from the center to your focus point here is 10 units long. So we know a squared, let's say. We know c squared, the distance to the focus. What we don't know is b squared. So to find b, we're going to use that formula that we talked about. C squared equals a squared plus b squared. So plug in the values you know. We know 8 is a distance for a. We know 10 is a distance for c. So it's 10 squared equals 8 squared plus b squared. So 100 equals 64 plus b squared. So 36 equals b squared, which means that 6 equals b. And that is what we put up here for our b value. We'll say 6 squared. Now, notice we're centered at the origin 0, 0, so it's just x squared and y squared. No h's, no k's yet. So you might be wondering, okay, Ms. Hanson, that's great that we used our formula from up above to figure out what our b value is, but what does that really mean on my graph? Well, it means this. This value here is your b value. You're going 6 units up. And what this gives us is it actually gives us a box. Let's see if I can draw it on here for us. a box that goes up 6 units in both directions, out 8 units in both directions. So this here, it's like an invisible box. Obviously, it's not really part of your graph, but if you can imagine this invisible box being there, we have invisible asymptotes running out the corners of this box. And these asymptotes tell us how the graph curves. So the graph will hug the asymptotes but never touch. So that's what these arms are doing here. They're hugging but never touching those asymptotes. So when we graph these by hand, that box will be more important. If you're already given the graph, like we are here for A and B, you don't have to actually graph the box. Doing the numbers down here is all we need. So let's look at our next one. We're also centered at 0, 0. The distance from the center to our first arm here is 3 units. And then to the focus from the center is 1, 2, 3, 4, 5 units. So we know C, we know A, we don't know B. So we're going to have something minus something equals 1. Because this one is going up and down, it's going to start with y squared because it's going this ways. And then we'll have x squared over here. We don't have to worry about anything because it's at the origin, 0, zeros. Underneath the y distance, we're going 3 squared units. We need to figure out what the x distance is, and we're going to again use that c value to help us. So c squared equals a squared plus b squared. So 5 squared equals 3 squared plus b squared. 25 equals 9 plus b squared. 16 equals b squared. So 4 equals b. So this is 4 squared. And that's our equation. All right, so let's try graphing. First of all, make sure that you are in standard form, meaning that you have a 1 on the right. Find the center, and if it's just x squared and y squared, it's 0, 0. Find the vertices, again, where it closest points are to each other. This is where it becomes important to draw our box. We're going to draw the box for those asymptotes. So I'll show you how to do these pieces. And then we're also going to find the foci using this formula here. So this should not be vertices, this should be foci using that formula. All right, so let me show you how we do this. In our first one here, we are already in standard form. It's just x and y squared, so our center is 0 and 0. These numbers tell us how far we're going to travel in both directions. So we're going to start by centering at 0, 0. We're going to go 2 units, because that's a square root, 2 units up and 2 units down, and that means our hyperbola is also going to be opening up, down, because y is first. And then when we go 3 units to the side, this is going to show us how big that box needs to be. There's going to be a box, this invisible box, that goes out 3 units and up 2 units in all directions there. And then through the corners of this box, run these diagonal asymptotes. So you can draw those in there. And then actually, once you have that, you have enough to draw your shape. Start at the vertices and just curve up, just kind of gently, and make it fit inside your asymptotes. Those asymptotes are going to tell you how narrow or how fat the arms of your hyperbola get to be. Now we have to label some things over here. So vertices, we're at 0, 2, and 0, negative 2. To find the foci, we're going to have to use that formula, c squared equals a squared plus b squared. It does not actually matter which one is a or b because you're adding them. Ellipses, it really did matter. A was always the larger number. For hyperbolas, it doesn't. We just take these two numbers and add them together. So 4 plus 9, c squared equals 4 plus 9. So c equals the square root of 13. 13 is approximately 3.5. So we'll say from 3.5 here. So it's about 3.5 units. So on our graph, from your center, go 1, 2, 3, and a little bit more. 1, 2, 3, and a little bit more. Your foci, your vertices, and your center will always all lie on the same line here, the same axis. They should always line up. So when we're trying to write the foci here, think about your center. You're still at 0 in terms of x, so it'll be 0 comma something, 0 comma something. You went up root 13 units from 0, so 0 plus root 13, 0 minus root 13. And then lastly, for your asymptotes here, we're thinking about the y equals mx plus b equation of a line for these dotted asymptote lines. Because you're going through the origin, the b is just going to be plus 0 at the back. So we just need to worry about the slope. So y equals, from your center, we rose 2 and went over 3. That's this positive asymptote that you see right here. Up 2 over 3, so it's 2/3 x. For the negative one, you went down 2 and over 3, so negative 2/3 x. So y equals positive 2/3 x, y equals negative 2/3 x. Those are your asymptotes. All right, let's look at another example together here. This one, you're still centered at 0, 0. The value underneath your x is 1 unit, so those are going to be square root 1 unit away. Those are your vertices. The 9, square root 3, tells you about your box. So here's your box. 3 units away. And then your asymptotes on this one are going to be really steep. Running through here. And now you can put in your hyperbola shapes. And that's your graph. Now let's talk about labeling what we know. Vertices are falling at -1, 0 and +1, 0. Foci, again, we're going to have to use our formula for this one here. C squared equals A squared plus B squared, so C equals square root 10, which is about 3.1. So 1, 2, 3, and a little bit more. 1, 2, 3, and a little bit more out. Telling what your foci are here, you're going from 0 back root 10 units, so negative root 10, comma 0, and from 0 forward root 10 units, so positive root 10, comma 0. And then for your asymptotes here, you are rising 3 and over 1, so 3 over 1x, plus 0 is your y-intercept. So this is just y equals 3x. And for your negative one, you have y equals negative 3 over 1x. You're dropping down and going over 1, so y equals negative 3x. So these are your asymptotes there. When you have equations that are not set equal to 0, like this one, you have to make sure that you divide everything by the outer number to get it into standard form. So this cancels. We're going to have x squared over 16 minus y squared over 9 equals 1. And then with our first one here, we're still at 0, 0. H and K are 0 and 0. 16 is 4 units out. 2, 3. For our vertices. And then the 3 is going to tell us our box. So here's our box. And then the asymptotes running through the corners. And then go ahead and make your arms of your hyperbola. All right. And now vertices, -4, 0, +4, 0. Foci, c squared equals a squared plus b squared, so c squared equals 25, C equals 5. 1, 2, 3, 4. There's 5. 1, 2, 3, 4, 5. So you went negative 5 out in the horizontal directions. And if you're asymptotes, you're rising 3 going over 4. So y equals positive 3/4 x plus a y-intercept of 0. And you're falling 3 units over 4. So negative 3/4 x plus 0 for your asymptotes. We'll come back to other hyperbolas with centers other than the origin in our next lesson.